Okay, so this is Unit 1, the 1.1 quiz. For question 1, it's a little tricky. The vote itself would be counted. The question asks for the number of doors, though. There's door 1 and there's door 2, which kind of led toward counted, but they're really categorical because the 1 and the 2 themselves are just really labels. And so there's door number 1, door number 2, those are categories where the participants are placed in. So that's why that one's categorical. Question 2. When your class participates in an internet game show and counts the votes for door number 1 and door number 2, the counts are examples of what kind of data? So now you're talking about, okay, we're counting how many people are behind door number 1. So you are counting them. That's why you want to go with counted. Measured is used if it's a measurement like it sounds. So for example, you might measure height. You might measure, if you were measuring the height of the participants, that would be measured. But here you're just counting the participants. If you were measuring length, if you were measuring time, things like that tend to lend towards measuring. Counted, it's like it sounds, it's more like you're counting numbers. Um, and so if you're counting something, you want to say counted. And then it is numerical because, which you got there. But numerical is, if it involves numbers, which this would. So that's why it's counted instead of measured. Okay, number 4. Which of the following would be an example of the use of inferential statistics? Inferential statistics are statistics that you're taking, you're making an inference or a guess about a larger population. So you might know something about, like let's say you were studying a high school and you only took a survey on every 10 students out of ninth grade, 10th grade, 11th grade, and 12th grade. So you really only had 40 students in your survey. And you decided, these students like hot dogs for lunch. And then you made the inference or the guess that, okay, well, I think that entire high school that they would say they like hot dogs for lunch. So inferential is taking we call it a sample, a part of a population, and you're making an educated guess or an inference about the entire population. So number 1, you have your entire class's math grades. That's why that one is not inferential, because you're calculating the average for that class. So you have that entire class's math grades and you're averaging that entire class's math grades. So you're not making a prediction about a different class. It's just it's called a description or a descriptive statistic of that class, because you actually have the class's grades, so you have the facts there. So descriptive is more based on what you actually know for sure, without a doubt. Okay, situation 2, you have your entire class's math grades and you use the grades to find the average math grade for everyone in your school who's taken the same math course. So in that case, you only have information on your class's math grades. You're making an inference about the entire school. And so that is a situation where you have a sample, which is your class. You're making an inference about the larger population, your school. So that would be inferential. Number 3, you have your entire class's math grades, and you use these grades to estimate the average math grade for the same math course at another school. Again, that's a situation where you're taking a sample. Your sample in this case is what's highlighted, the entire class's math grade, your class's math grades. You are making an inference or a guess about another course at a different school. So 2 and 3 are inferential. Number 1 is descriptive. Okay, number 5 these questions start to get tricky. It says you want to know something about your neighbors, so you give them a survey. The survey collects the following data about each family on your block: family size, the kind of pets they have, the grade of the youngest child in the family's annual income in dollars, what the dad does for a living, whether the mom works, and their phone number. Each kind of data you collect about a family is a variable. Which of the variables you collect are continuous data? One way to think of continuous data that might be helpful in this situation is that continuous data can take on any fraction or decimal. It can include any value, in other words. Grade, you're close here, but grade of youngest child, you can't include, we don't say grade 1.5 or grade 2 3/4. And so that would be why that is not continuous. Annual income is, because if you calculated it, you could get down to the nearest cent. You could get, technical too there and say, well, there really are beyond hundredths of a cent. You could probably calculate even more decimals there, but really you want to just ask yourself, is it a measurement or like a continuous type scale? Including decimals and fractions. If so, then that's continuous. Question 7, the same survey, you're wanting to know what other categorical variables there are, so besides phone numbers. Categorical variables, you really want to ask yourself, could I assign a label or a letter and have the same meaning? So if you are looking at the grade of the youngest child, we could assign grades. We assign grades 1 through 12. But if you even think about kindergarten, we assign a letter to that. So we could do grades, A, B, C, D, E if we wanted to, and that would really mean the same thing. Dad's occupation, we could say, okay, well, if you're a firefighter, we're going to call that A. If you're a police officer, we're going to call that B. If you're a teacher, we're going to call that C. And so you could assign a different label to that occupation. Same thing with, location of where mom works. Kind of pets, same idea. You could do cats are A, dogs are B, etc. So that's one way to kind of look at or make the distinction between categorical. Another way to think about it is say, okay, well, grade of youngest child, that has numbers that go with it, but mathematically, do they mean anything? If I averaged grades 1 through 12, would that make sense? So no, we don't really say, well, that your average grade is 5 3/4. It's kind of like, well, what does that mean? So that's, that might be helpful too. Question 9. Yeah, so the one that you can't have is continuous and categorical. So because categorical doesn't really have any mathematical meaning, and then continuous usually does. So in other words, categorical, you don't have any mathematical meaning. So in other words, if you assign a number like grade, we were just talking about grade, if you assign 1.5 to it, that doesn't really make sense, and so therefore it wouldn't be continuous, because continuous means that you can have fractions and decimals. And then this one, I kind of don't like this question, to be honest with you, just because they don't really, the way they explain it, it does seem like it would probably be discrete. And then their argument here makes sense, but I think the way they kind of hinted at it, it makes you want to say true, that it would only be discrete the way they described it. The key here, and this is kind of the overwhelming theme, is if it's a measurement, you can think of it as continuous, or the way they described it in the question, you can think of it as discrete, and so that's why they put false and explained it like this. So just say, well, even if they're describing it as discrete, if it is a measurement, you can also say continuous. And so in that case, that will kind of make you, or help you distinguish that, yes, you can say continuous and discrete. I hope that helps. Let me know if you still have questions.